Congratulations. You folks have made it this far on the last day to the penultimate talk. So congrats. With that, raise your hands if you're still awake. Be honest. That is more than I expected. Okay, so keep your hands up. Up. Keep them up if you're using Kubernetes in production. Some of you, this may not be the right talk. I'm glad you're here. Keep them up if it's managed Kubernetes. So EKS, GKE, that sort of stuff. Okay, but what I'd expect. Good news, you can still use this stuff, even if it's managed, unlike a bunch of other stuff, but that's beside the point. Are you already using dynamic emission control? Keep them up if you are. No? Okay. Last but not least, is anyone using Kyverno or something similar for doing like policy, like checking whether stuff is... Okay, cool. They're using this. Whatever they tell you is a lie, they're using this. But anyway, so you can write it yourself. Now, with all of that out of the way, if you fall asleep, this is what you would have got out of this. Here you go. Don't worry, I've got you. All right. This is human created, but there we go. For the couple of people who aren't using Kubernetes, it does this and some other stuff. That we know what Kubernetes is, I'm going to explain what an API request to Kubernetes actually goes through. This is the simplified view, but you're a user, you make a request, you're creating a pod or something, it goes to the API server, which checks, are you allowed to do this? Is it conformant with the schema? Is it sane? It goes through all the emission control stuff, which I'll talk about later. Then the response is generated and it's sent back to you. This talk is about dynamic emission control. This is bring your own logic admission control. There is static emission control, which is built into Kubernetes itself. For example, pods, replica sets, deployments, that sort of stuff is already built in. Now for the meat. I'm going to be walking you through this. Not all at once. It's not as scary as it seems. Dynamic emission control. What is it? This. This is what's in the official Kubernetes docs. I've paraphrased slightly, but here we are. They are HTTP servers that you can run, and you tell Kubernetes, talk to me whenever any of these resources match, and I will tell you some stuff. First in this queue are mutating webhooks. Okay, what do? You tell Kubernetes, I'm interested in something. I'm interested in pods. Send me pods. Send me anything to do with pods. And I can optionally mutate them. As an example, you're running workloads on multiple clusters, and you want to use the same configuration everywhere. For the mandate from on high is same configuration every cluster. You're going to use different registries for different clusters. You're not going to use the same GKE or a Google registry on Azure, for example. But you could have a mutating webhook that injects that registry address in any image. It rewrites it for you, so you can have the same configuration and the cluster will do the heavy work for you. Another example would be adding default annotations on a namespace. So say you have cost attribution, you're telling teams, no, really, you need to tell us which budget this comes out of, and they're not doing it. You just go, okay, by default, it comes out of your holiday, or something maybe less malicious than that. This comes first. Next comes validating admission policies. So these are in beta as of Kubernetes 128. I'm not sure if they've graduated yet. And the point of this is, remember I said you have to have your own HTTP server. Specifically, you have to have your own HTTPS server. Wouldn't it be really nice if I just didn't have to bother doing that? So that's what validating admission policies are. You put this into Kubernetes and you say, if this stuff matches, do some things. And I'll walk through that in a moment. It's written in common expression language. Hands, who's had the misfortune of dealing with this stuff? Okay, who uses Google, like Google Cloud or anything? Yeah, you're already using it. It's the thing that they do all of their logging policy stuff in. So you have the misfortune of talking this stuff. And yeah, you can use this for yes-no validation. So it's just validating. So the only thing that you can do is tell Kubernetes, this isn't allowed. You can't change anything. Here is an example from the Kubernetes documentation. What is this doing? That's all this is doing. The rest of this is a name, a schema version. It's saying, I only care about deployments, and I only care about them being created or updated. Only send me that. Only evaluate this against that. And make sure that people don't spend too much beer money. So the replicas are below 5. One other piece that can be relevant in this is the failure policy. I'm going to talk through some fun implications of that later, but this is you telling Kubernetes, what happens if I wrote that wrong? What happens if it fails? What happens in the bad cases? Does Kubernetes just go, no, you don't get to come in? Does it go, whatever, I'll just let you through? Does it do something else entirely? So, a slightly more realistic scenario here. You're saying, again, most of this is metadata, but on the right, you've got a pod. And you're saying it's in the production namespace, it's a sensitive workload, but I'm going to use the default runtime class. Just by default, right? So it's using containerd or something. And what you've got on your left, again, the very bottom line's about the only relevant part, is if it's in the production namespace, basically the runtime has to be gvisor. If it doesn't, it fails. And failure policy is fail. So what you're saying is, no, these pods don't get to start. They have to have the isolation, they have to be using that, or else that pod doesn't even get scheduled. It doesn't get to exist. It doesn't even get to be an API object. So again, the pass case is the first commented line, the failure case is the second one. What comes after the validating admission policies? Validating webhooks. So again, this is the more traditional way. This is, you have an HTTPS server somewhere, it posts over to you, and you decide whether it's allowed in or not. The main difference between the validating admission policies and validating webhooks, other than ease of deployment, is that your webhook can do whatever you want. It's a binary you wrote, it's a binary you ran. If you want it to make its own API calls and then do some logic based on that, which you really shouldn't. Like I talked with, I think it was Sig Auth about this, and they're like, please, for the love of God, don't make your webhooks have side effects. And I was like, haha, here's some stuff I wrote that has loads of side effects. But anyway, so now that I'm on it, why shouldn't they have side effects? Your webhook can be called more than once per object. Depending on race conditions, whatever, you'll get to see things at least once, but you may get it more than once. If an object was mutated, then it gets sent back out to all the other mutating webhooks. So they get to decide whether they want to or not again, etc., etc. What does the flow look like here? So it comes in, it goes through static, admission, then all of the mutating webhooks are called. If any of them change it at all, the other ones get called. If any of them reject, that's the end of it. It's just rejected, surfaces back up. If it wasn't rejected, then it goes on to your validating admission policies. They again are invoked in whatever order they feel like. Any fail, rejected. If they don't, it goes on to the next step, which is your validating webhooks. And again, you can do whatever you want there, and then it's sent back out. This is what they look like. Minimize. Jason, don't you just love it? No, but really though, this contains a bunch of stuff, and okay, what was in that? What does it actually look like? So you get the full original request, you get what made it, and you get some metadata. That's what's in there. Now we will see whether this video works. All right, this is what it looks like when it's unminimized. Again, you have your usual metadata, you have what operation happened, who did it, and then the original object. And I scrolled through far too quickly in the past. But anyway, you have the new object, you have the old object. So say, for example, you did a mutation, and you have what called it. See, in the preview, this showed the first bit of it before I click play, but that's beside the point. Anyway, you get to see what groups was the user in. Was it even a user, etc., etc. So you can do your own more advanced logic on top of that. No, it's not. All right. One more thing. When are these called? On mutations, creations, deletions. I know both of those count as mutations, but bear with me. Read-only stuff doesn't go through any of this. It only goes through static emission control. You can't mutate a read-only like API call. That doesn't make any sense. They'll be really handy. But anyway, all right. So we've had the video. What are the limitations of these systems? At every stage, you get to choose whether Kubernetes will feel open or feel closed. This means if you choose to have them feel closed and you have a bug, or your webhook is down or anything else, all your matching requests will be rejected. Every controller that's trying to do something, so you have a Kubernetes operator that's like trying to do a whole bunch of stuff and spin up a pod, but you're blocking all pods, it's going to go nuts because it's not going to understand, what do you mean you're not allowing my request? So yeah, that can happen. Also, these can't operate on these resources. What do I mean by that? You can't make a validating webhook that blocks you updating validating webhooks because then you could lock yourself out. This is a good piece of design from Kubernetes, sometimes very annoying, but again, you can actually recover yourself from these, but it is a limitation to be aware of. Take time to process. The minimum timeout you can set on your webhooks is 1 second. That's a long time. That's the minimum. The default is 10 seconds or something. If you have it on the hot path, if you're doing a whole load of near real-time stuff, some K8s serverless thingamidiffer, that's the minimum timeout. That's all you got. So that's a bit annoying. Yeah, and again, you could get a request that you already dealt with. So say you're mutating webhook, you could get the request you mutated back again. And if you then try and do stuff, you end up in an infinite loop. And that's really a lot of fun. You can end up filling up etcd and taking down a cluster. Ask me over a beer afterwards about that one. But yeah, you can't lock yourself out of a cluster here, but you can give yourself a really bad day by overloading the cluster with this stuff. All right, how can we have some fun? Here's the boring bit. Here's some real vaguely useful uses of this stuff. You can see whether you have enough quota. If you're not doing a bunch of custom resources, you might have a thing. Say you're doing some grid computing thing, and you have a team and they get a certain amount of quota. You get to use 1,000 CPUs overnight, but not the rest of the day. Kubernetes by default doesn't really have a native way of doing this. So you can do this here. Again, side effects, which the maintainers really don't like. But again, you could do it. I would recommend talking with your teams first and getting them to set their default workload IDs, workload user IDs. Don't run as root, run as some other user. But you may be in a large enough business where that's just not an option, or you're running a managed service and you just say, no, really, I don't care what you say. I'm setting your user to this number. You could do it here. You could force a naming convention this way. Like if it has to be department, team, workload for tracking purposes, auditing purposes, whatever else, you could do it this way. You can have the list of like, it only conforms to these things. All right, misuses. We've heard a bit about chaos engineering. You could do it. I don't recommend it, but you could. You can totally just insert stuff that kills all the pods. So yeah, that could be an option. More seriously though, like that might be of interest for some teams. Like maybe if you can't install extra things, you have the consent of the team. They're like, look, we really want to know what happens if we have like, an unscheduled shutdown of something. What happens? You can go, cool, let's do that. All right. Yeah, red teamers love this stuff. You can just send whatever you want out. I'm not going to ask who works for cloud vendors, but basically this works on all the managed Kubernetes. There is a vendor who has a way of blocking this. I'm happy to name them afterwards, not on recording. But yeah, in general, you can just send out a bunch of data like through this and send it wherever you want. The cloud vendors won't block that. Even if you have your own cluster, I've forgotten the researcher's name, but there's a researcher who wrote something called, I believe, like K8s port scanner or something. And you can essentially just like fuzz networks through the control plane. So you can get up to some real mischief here. You could listen to any mutations, creations, deletions, and you could make your own audit log. Say, for example, you're running on a cloud vendor, which makes it really expensive, and you can't get rid of things like subject self-access requests because they turn them on and it costs you 10 times as much money as it should. You could run your own. This is a project I maintain. I got a bit irritated, but yeah, this is how this works. Or you could register your own webhook to ask the coffee machine to make you a cuppa if certain team deploys something after 6 o'clock on a Friday or 11 o'clock on a Friday. based on one of the earlier talks. Just to repeat, here is what I have tried to imbue you folks with, a bit of knowledge. And here are some useful resources about what I've been talking about. Diagrams in this talk will be part of the Kubernetes API docs at some point, but they have a bug with Mermaid.js, so I'm trying to work out how to get that in. But yeah, also happy to send these afterwards. And with that, questions.
If someone has implemented this and I try to deploy something and I get back that's not allowed, is there a way to without looking at from the exit code or for something like that is blocked by the dynamic admission controller, that so that I know that I have to look for that? Or
so you can, so in the request you can surface up like the failure reason usually, and that would get sent back to the original. Will also show up in the audit log. So if you are running the audit log, there will be metadata saying the policy decisions that were made. So you'd be able to see in the audit log, oh yeah, this was rejected for this reason. Also, there are metrics. So if you're scraping the metrics from the control plane, there are metrics for all of these API calls that the control plane is making. And you would be able to see an uptick in metrics there.
So you mentioned the request that gets sent contains the requester and the object.
Yes.
And then you also mentioned that if you do mutate that object, you're then back at the top and you potentially rerun 3 more mutations.
Yes.
You then could potentially have a bunch of mutation chaining. How do you then lose track of who the original requester was? Or does the mutation not get counted as something that called the object?
So the thing that's being mutated is what I'd describe as the target state of the object. You're updating what the pod is going to be. In your system, none of these things won't be showing up in the request that's sent to each of them. You'll just see what the target state was designed to be. If I, Richard, am running an API call, the API call is still attributable to me. But again, through the audit log, through everything else, you would see what changes the request I sent you went through. But it's still attributed to me, if that makes sense. Yeah.
Sorry, I'm new to this stuff. I was looking recently at trying to delay an update of a service.
Mm-hmm.
Is it bad practice to use a validating webhook to wait until something happens before you say, yes, okay, you can go and do this? ChatGPT seems to think it's bad practice.
Yeah, this is a hammer. Don't use it on everything.
Yeah.
In fact, usually if you're thinking you want to use this, don't do it. Do something else. I'm more showing this for completeness rather than, please go off and use this magical API. In that case, it really depends what you're trying to do. My guess is what you're actually trying to do would probably be better as part of a deployment pipeline. Or if you've got some advanced orchestration logic, that should fit in an whatever's orchestrating it. So if you're using an operator to orchestrate the things, it should sit there. If you're using a pipeline, it should fit there. I'm happy to discuss afterwards in a bit more depth of what you're actually trying to do, but
yeah, I think it was me just trying to find a hacky quick way of not writing an entire operation.
Yeah, of course. But yeah, we can chat afterwards. Again, depends on exactly what you're trying to do.
Thanks.
Yep.
Would this be a good way to enforce that application teams, cluster tenants set the resource and request limits on their manifests?
It is a way that you could do that. The main thing would be making sure that it surfaces to teams why things are going wrong. So as an example, the pod will be the wrong place to surface this because the deployment is just going to make a replica set that's going to keep trying to make pods. Like it's just going to keep going and keep going and keep going and just not work. And the dev team are going to be like, why don't I have an update? The thing, I deployed it. Why isn't it working? So yeah, you could do it at like the, say, deployment level or stateful set level. But again, if their deployment pipeline isn't paying attention to the responses it's getting back, you're going to have a lot of confusion there. If you're in a huge organization working against different verticals, something like this might be the way to do it. But if you can actually talk with the devs at all, talking with them and helping them put in like a test in the pipeline or in the repo or something is going to be much more effective from like actually getting the change you want perspective.
Yeah, so we tried that, but they still don't set the request limits, and that's why I'm looking for a technical solution.
yeah, then you can do this. This is your hammer to enforce whatever you need to enforce, right? Any further questions? I will be about. I'm in a bright green t-shirt and a light grey hoodie, probably about the only Northern Irish person here, so come ask me questions. Thank you very much.